Chemical reaction engineering. Basic concept of chemical reaction or chemical kinetics. What is chemical kinetics is? Chemical kinetics is a branch of physical chemistry which used to study the effect of temperature, pressure and concentration on the rate of chemical reaction. And also it is used to find out the mechanism by which the chemical reaction takes place. The next one is the rate of chemical reaction. What is rate of chemical reaction? Change in concentration of reactant or product in a particular time is called rate of reaction. Depending upon the rate of reaction, there are two types of rate of reaction: average rate of reaction and instantaneous rate of reaction. As the rate of the reaction is change in concentration of the substance, either change in concentration of reactant or product in a particular time. The change in concentration with the time, the unit can be written as per mole of a substance and in given time. So, mole power minus 1, second power minus 1 or mole power minus 1, minute power minus 1 is the unit of rate of reaction. Consider a general reaction. The small a moles of A reacts with B moles of B to form C moles of C and D moles of D. Here A and B are reactant and C and D are product. As the time passes, the concentration of A and B decreases with the time and the concentration of C and D increases with the time. So, the rate of the reaction expressed as, here the reactant concentration decreases with the time given by minus sign, where the number of moles written like this, and the concentration of C and D increases with the time given by plus sign. So, this one is the method of expressing the concentration. The concentration decreases given by minus sign, the increase in concentration with the time given by plus sign. Depending upon the rate of chemical reaction classified as two types: average rate of reaction and instantaneous rate of reaction. Average rate of reactions gives the total change in the concentration of either reactant or a product to the total time taken for the reaction to complete. This ratio will give you the average rate of reaction. Total concentration change with the total time taken. This ratio will give you the average rate of reaction. This graph shows what is the concentration change takes place as the time passes. And next one is what is instantaneous rate of reaction. The instantaneous rate of reaction shows the rate of the reaction at any instant of time. When the time interval is very made small, that rate is called instantaneous rate of reaction. In this, the change in the concentration with the time, the slope, and actually that any instant of time, the rate of the reaction can be calculated equal to the slope of the tangent to the curve. The slope of the tangent to the curve will give the rate of the reaction at any instant of a time. Here, for example, for the reactant A to form B, at the rate of the reaction at any instant of time that is limited to a particular time will be calculated, that is minus dA by dt, the decrease in the concentration of A or the increase in the concentration of B with the time at any instant of time can be calculated. So, depending upon the rate of the reaction, there are two types: average rate of the reaction and instantaneous rate of reaction. Next one is the term called rate equation and also rate constant. Now, consider reaction A and B to form C and D. Here, the rate of chemical reaction is directly proportional to concentration of A and B. Here, to remove the proportionality factor, we are writing the form of equation. We are introducing one constant called K, that is called proportionality constant. So, the rate of the reaction is equal to K, concentration of A, here the number of moles is raised to the power of concentration of B, where the number of moles are raised to the power of concentration of B. Here this expression, the rate of the reaction is equal to K, A power A, B power B. This expression is called rate equation, rate law of this equation. So, this expression actually relates rate of the reaction to the concentration of the substance and also the rate constant. This expression is called rate law or rate equation of this reaction. So, next one is we are going to see what is rate constant. What is rate constant is, now consider a one rate expression or rate law of a reaction. The proportionality constant present in the rate law or rate expression is called rate constant. Proportionality constant present in the rate law or rate expression is a rate constant. It is an experimental quantity, can be found only by experiments. The K depends upon the temperature and it is independent of initial concentration. At unit of concentration, when the concentration is unit, the rate value will be equal to K. At fixed temperature, and K is a constant characteristics of a reaction. Larger the value of K shows the faster the reaction, the smaller the value of K shows the slower the reaction. Molecularity of reaction. Molecularity of reaction defined as number of particles, that is atom, ion, groups, molecules of reactants actually taking part in a single step of chemical reaction is called molecularity of a reaction. Here it is given as taking part in a single step of a reaction, that is the rate determining step of your chemical reaction. Here the number of molecule present in rate determining step of a chemical reaction gives molecularity of a chemical reaction. Here the molecularity of a chemical reaction always a whole number, not zero, never be a fraction. And second point is the value of molecularity of a reaction is simple one step reaction and does not exceed 3. And it cannot be greater than 3 because more than 3 molecules may not mutually collide with each other. Depending upon the molecularity of a reaction, the reactions are classified into unimolecular, bimolecular and trimolecular. Here the unimolecular example, O2F2 decomposes to form O2 plus F2. And here the bimolecular reaction, the decomposition of hydrogen iodide to form hydrogen and iodine. The trimolecular reaction, here the example is 2NO reacts with chlorine to form 2NOCl. So, the example of unimolecular, bimolecular, trimolecular reactions are given. Now, we are going to see how to calculate molecularity of a chemical reaction. Consider a reaction 2H2O2, decomposition of hydrogen peroxide in aqueous state to form water molecule and oxygen. Here the mechanism of chemical reaction is the reaction takes place in two steps. The first step is the hydrogen peroxide reacts with iodide ion to form H2O liquid, water molecule plus OI. And the second step of the reaction is the H2O2 reacts with OI to form H2O, I minus and O2. Here the first step is, here the reaction takes place in two steps. It is a mechanism of this reaction. Here the first step is slow step and rate determining step. In this only two molecules are present. Here in this two steps, the first step is slow step and rate determining step. In this two molecules are present. So, it is a molecularity is 2 for this reaction and it is second order. So, the number of molecule present in rate determining step which used to determine the rate of reaction and also called a slow step. In this step, the number of atoms present is 2. So, the molecularity of the reaction is 2 and it is a second order reaction. This is a method of calculating molecularity of a chemical reaction.